In this video, I'm going to continue how to find the hybridization, the geometry shape, the magnetic behavior of some more complexes with the help of valence bond theory. Let's come to this complex. The atomic number of iron is 26. So the electronic configuration is what? Argon 3d6 4s 2. This one is your 3d orbital 4s 4p. In the 3d orbital we have 6 electrons, 1 2 3 4 5 6, and in the 4s we have 2 electrons. Okay, so here we have 0. So look here, now we want to find the oxidation state of iron in this complex. So how to do that? X plus 6 into the charge carried by Cn, that is -1, equated to -4. So upon calculating we get +2. So that means iron is in the +2 oxidation state. So for the +2 ion, what would be the electronic configuration? +2 means you are losing 2 electrons from the s orbital. So here we have only 6 electrons because 2 electrons have been lost from the 4s orbital. Okay, so look here, this Cn is actually a what? It is a strong ligand. So since it is a strong ligand, it causes these electrons to pair up. So what do we have? The electrons pair up. So we have in this way. Okay, so 1 2 3 4 5 6, these are your what? Your 6 empty. These are your 6 empty D2 sp3 hybrid orbitals. Okay, these are your 6 empty D2 sp3 hybrid orbitals. And here we have the same thing. Now these 6 empty spaces, or we say the 6 empty D2 sp3 hybrid orbitals will be occupied by the Cn molecules, by the 6 Cn molecules. That means these empty spaces will be occupied by the 6 electron pairs from 6 Cn molecules. Okay, so we see that from there, what is the hybridization? It is D2 sp3. Okay, if the hybridization is D2 sp3, what is the geometry shape of the complex? It is octahedral. Octahedral. Okay, octahedral. Look here, it is the D2 sp3. So this one is an inner orbital complex. Why? Because it's the d orbital of the, not the outermost shell, that is involved in the hybridization. That's why it is an example of the what? Of inner orbital complex. And what about the magnetic behavior? Does it have any unpaired electron? No, it doesn't have any unpaired electrons. So it is diamagnetic. Okay, diamagnetic. So that's all. Let's come to the second one. What is the atomic number of nickel? It is 28. So the electronic configuration is argon 3d8 4s 2. This is your 3d 4s 4p. In the 3d orbitals we have 8 electrons, 1 2 3 4 5 6 7 8. In the 4s we have 2. What is the oxidation state of nickel in this complex? So X plus 4 into the charge carried by CO, it is 0, equated to 0. So your X is 0. That means no electron is lost. So the configuration would remain the same. Okay, so now what about this one? This is a strong ligand. Since it is a strong ligand, what does it do? It causes these electrons to pair up. So what do we have? Okay, let it be in this way. So there will be pairing of electrons here. That means this one has come here, and these two come here. So here we have empty spaces. Okay, 1, 2, 3 and 4. So there are four hybridized sp3 hybrid orbitals of nickel. So what is the hybridization here? It is sp3. Remember that the electrons from here come here. Okay, that's why we have here the 4 empty sp3 hybrid orbitals, and these empty spaces will be occupied by the 4 electron pairs, by the electron pairs from 4 CN molecules. Okay, so what is the hybridization? Hybridization is sp3. Okay, sp3, 3 p orbitals and 1 s. If the hybridization is sp3, what is the geometry of the complex? It is tetrahedral. So look here. What about the unpaired electrons? Does it have any unpaired electrons? No. So because of that, it is diamagnetic. So that's all.